Okay, let's begin. So how to build an effective enterprise Kubernetes team. I'm Franz Schubert. I work for Giant Swarm, and I would like to take you through a couple of aspects on how to build an effective enterprise Kubernetes team. First, I will quickly cover what companies are looking to achieve by going cloud native. When we have done that, we will quickly look at things that you need to do to manage a cloud native stack. And once we have that as a clear picture, I will speak about the different possibilities to cover the tasks. And my goal for this webinar is to give you an approach how to make a smart decision on how to build your effective enterprise Kubernetes team and adapt that to your specific case. So not all cases are equal. There might be different priorities. And within these priorities, you might make special choices on how to move forward. You've all been muted, so we actually won't have a direct conversation, but you feel free to ask any questions. In your control panel, there is a question mark, which allows you to open a box and then type your questions, which I will get to at the end of this webinar. And if you don't feel like asking questions in public, you can send us an email to hello@giantswarm.io, or simply, if you attend AWS reInvent next week in Las Vegas, we would very much look forward to welcoming you at our booth and have a direct conversation about your engagements, your activities, and how we may be able to work together on getting you onto Kubernetes or cloud native in general, or help you advance in this respect. To make it a bit interactive, I decided to start off with a poll, which is how much you know about Kubernetes. I just published this poll. Give me a second. And would like to ask you to answer this question. So how much do you know about Kubernetes? I know about Kubernetes, but have not started. We have set up Kubernetes for our project, but we haven't gone live yet. We are fully in production on Kubernetes in a single project, or we are running Kubernetes for several projects in production, so at enterprise scale. I'll just wait a little bit for you to answer this question. So the numbers are coming in and mounting up, and I'll share the result in just a little while. Good. I think we have reached a decent amount. So I'll just share these results for you. So we've got 10%. I know about Kubernetes, but have not started. Then 35%. That's actually a quite high number. Is we have set up Kubernetes for our project, but not gone live yet. So they're currently developing, I guess, on the platform, migrating a legacy application or building a new application, microservice application, but not gone live. And those who have gone live, and that's quite significant, have gone live with several projects. So they're managing Kubernetes in real life. But I guess since you're here, things aren't as easy as they may have seemed in the beginning, or you actually would like to understand how you need to evolve over time. Now, this is very interesting. Yeah, so I actually hope that I've got something for every one of you here in this webinar. Yeah, let's, without further ado, jump in. So all content in this webinar comes from our extensive experience of running Kubernetes for our customers in production 24/7. We actually face these challenges every day. And I would like to share insights that we have generated throughout all the time working with our clients. And so you actually know it's not a perception on what theoretically should happen, but what actually happens from a practical standpoint. Before we started off Giant Swarm, we ran a data-driven advertising platform with over 10,000 requests per second. So we had to make sure we had a very reliable platform and scalable platform, but that would also cater to our needs to constantly drive innovation. And managing such a platform and at the same time allowing for such a high innovation rate was quite painful. So when we sold the business and were pondering about what we should do next, we quickly saw an opportunity to really help companies that are thinking about moving to cloud native, to help them by taking over the building and managing the whole platform for them, so they could then focus better on driving digital products and especially unleash the whole power of cloud native, which we will turn to in a second. We were founded in 2014, so that's about 5 years old in Cologne, Germany, but we are scattered all around Europe with probably employees in over 20 countries. And we have been focusing on Kubernetes from the very beginning. So this is something that turned out over time to be a very smart choice, since Kubernetes by now is the de facto standard for container orchestration, and it is advancing at an unbelievable pace with over 85,000 commits and many people active in this space. So there's a lot of development happening, and this is something that all companies are engaging with, thinking about going cloud native. And the reasons for going cloud native are pretty obvious. One is that companies are challenged by new market entrants that have taken a digital first approach. So they are looking at digital innovation, being faced with digital innovation that they need to catch up with. And that actually comes down to, I know there was this famous quote of software is eating the world, which basically means that software is the key differentiator for many companies today. And so cloud native holds for them the value of really speeding up development, making the most out of the development capabilities by abstracting lots of functionality into the infrastructure level. So basically the teams can focus on driving forward what really sets them apart as a company, or come up with new digital products very quickly. And the idea there is actually to really come out with the first iteration, minimal viable product, and then iterate from there. That means going on and on with continuous integration, continuous development, continuous deployment into the production environments, really understand how customers are using this and accelerate deployment cycles. So you then basically come to and can develop new markets a lot faster, and really capture markets, but also develop new opportunities for your company to evolve on. The beauty about cloud native is cloud is a part of that word, that you naturally have a higher scalability going to the cloud. You've got lots of cloud providers that heavily invest in data center resources and provide you with these capabilities, so you can then easily scale up or scale down and basically pay only for the functionality or for the services you need. And at the same time, cloud native also provides you with the capability of enjoying improved resilience, because you've got failover structure that helps you update, upgrade a node during life or during production without any downtimes. Also, if there is a failure, then the other nodes will take over and basically provide your customers with the service that you offer without having to worry about the time and the energy you need to put into bringing the node back up that then basically complements your full set. So with these cloud native advantages, it actually becomes very clear that companies are focusing on how to engage with cloud native. And so we will now quickly look at what a potential cloud native stack would look like. Typically, you naturally start off with this physical infrastructure. Either this is on-premise with you, so you've got your own data center where you've got your machines, you've got your network and everything, or you basically get that from a cloud provider. The cloud provider, and that's something that companies have used for many years now. It's a virtualization layer that helps you make more efficient use out of the machines that you have to your availability. And cloud providers use that extensively to make sure that they can provide the compute resources that their customers need across a wide range of data centers, of machines, of memory, and so on and so forth. So basically, they can help the companies scale and provide them with the services they need very easily in a virtual environment. On top of this virtualization, that's where you build the cluster orchestration platform. In our case, this would be Kubernetes, that then basically helps manage the clusters and the containers that you build your microservices on, or deploy your microservices in. So that's where, so to some extent, the microservices covers the aspect of the container that you need to establish to run them on, and then also your custom microservice that you have developed and deploy to then basically provide your service to your customers. Now, if we think about how to set up a good team for your for managing the whole stack, then it actually makes sense to split this up in two sections. One is the focus on technology, which basically covers every aspect of the stack. And also the 24/7 operations, which is something that you need to take care of, either yourself or have someone take care for you, so everything stays up and running. Let's start from the very, very bottom. So we've got the physical infrastructure with the servers, the storage, the racks, and you probably all know that if you run an on-premise installation, you need to take care of these, make sure that you have everything set up, starting with the servers and the storage, up to cooling, security, fire alarm systems, and so on and so forth. That typically is handled by a public cloud provider or a data center that you may have use as a service. And what you need to do, either by running it yourself or by using and consuming these services, you need to monitor, you need to identify issues, you need to resolve them. You need to make up your mind about how to create a failover architecture, disaster recovery if anything happens. So there are many, many aspects that you need to cover, and that in many cases are quite dominantly covered by public cloud providers, including OS management, so upgrades and hardware replacements and so forth. On the virtualization layer, you basically have the VM software that can be open source or VMware or some other provider that helps you to abstract your physical and hide your physical machines from basically your developers or your applications, and provide them with the resources, computing and storage resources they need. Still there, you need to configure, you need to provision and upgrade this element, which in part is taken care of by public cloud providers if you use them. Then you naturally have the cluster orchestration platform, where you need an operating system, you need to take care of networking, security, secrets, cluster, operator software, and so on. So there are lots of software pieces that you need to, that basically extend Kubernetes at the core, and then they these additional applications take care of all these other aspects that you then help you provision the different clusters, make sure that you can monitor them for daily operations, so where you need to do upgrading, logging, security aspects, where you specify and audit, test, and maintain the security, also networking that needs to happen within, so from external to internal, but also within the different clusters and networks. That's what we'll be covering further up in the layer. But you also need to make sure that you monitor everything, that you identify issues, isolate them to make sure that you can identify the root cause and resolve them by either upgrading or fixing them all by yourself. And then in the cluster, you basically have the same. You've got the operating system within the cluster. You've got the orchestration system, networking, security. So basically many things that you already have specified on the cluster orchestration platform, you need to specify in the cluster as well. You've got your software to do that. It can be for security, Aqua, for networking, can be a Calico. So there are many projects surrounding Kubernetes that help you take care of all these aspects that you need to make sure and provide to establish a good foundation for your cloud native application platform. And here, as already said, you also need to take care of 24/7 monitoring, make sure that upgrades happen, make sure that security is specified and followed, that you can identify issues, that you can take care of load balancing. So there are many aspects that you might want to take care of in this layer. And then basically when you have your application and you install your microservice in a container, then you've got your custom microservice naturally you need to take care of and monitor. Then you've got your container-based image that runs within your container or specifies your container. Then different agents like logging, alerting, monitoring. Here also to make sure that this highly volatile system always provides you with the accurate insight into if everything is up and running and if things are working very nicely. So here basically you also have the need to provision different containers. You need to operate them, you need to upgrade, monitor, log them. So there are many aspects that, as I said, you need to cover to make sure that everything stays up and running. So this might sound a lot, and it actually is a lot, but to put more meat to the bone, I just put some points together that what we actually do on a daily basis to provide our customers with such a platform. So within Giant Swarm, we've got one team per cloud platform. That means we've got one for AWS, one for Azure, one for on-prem, and they basically make sure that the setup is very current, that they constantly extend the cloud platform, make sure everything is nicely integrated, make sure that new technology is evaluated and potentially replaced. If there are new developments coming out that cover certain aspects or provide capabilities to support certain use cases for customers, that's what the cloud platform team does. Then we've got one team that just takes care of observability. That means making sure that all these different tools that are used that surround Kubernetes and Kubernetes itself provide us with the data that we can then basically use to log and monitor. One is naturally monitoring and alerting in case something goes wrong, but also logging to make sure that we can quickly identify the root cause of an issue and go in and fix it. And then we naturally have site reliability engineers, which you probably have yourself, that then take care of making sure that the cloud native platform supports the use case you have, that it actually is very reliable, that the architecture is set up in a way to support the required level of failover and uptime that you expect. And then we have a dedicated solution engineer working with every customer. This is something that we also extend for our customers, but they typically also have an own DevOps engineers position and team that helps the development teams and helps them understand what the cloud native infrastructure provides, helps them understand how everything works together, what they need to consider, how to architect things, what upgrades are going to come, how that will impact the application. So there are many aspects that need to be covered, and we basically see our customers having 5 to 10 people on the DevOps engineering side, just enabling the team, making the most out of a cloud native platform. And that is really helping them either rebuild their monolith or extending it or building a new application. So there are aspects that they can really help to make the development of cloud native applications really fast and highly efficient. In terms of so these are the different roles that we basically see in managing the whole stack. But then there are also aspects that might also be interesting to some of you that haven't been in touch with Kubernetes too deeply. One is that there are major releases coming out every 3 months. So the development, as I said, is happening at a rapid speed. Around Kubernetes, there are about 250 projects in the Cloud Native Computing Foundation that covers certain aspects. As I mentioned, it can be a Calico, it can be a Prometheus, it can be a Grafana, and so on, that then help you cover certain aspects. And these are the most frequent ones that I just named. There's also the Elasticsearch and so EricStack, Kibana, and also Fluentd for the more modern ones. So there are many projects that we typically install for customers upfront because we know that they need them. And then there are many projects that you may use for certain use cases to either support just big data analytics, or that help you support IoT use cases, and so on and so forth. So there are many projects you might need to get your head wrapped around and then basically integrate into your cloud native infrastructure. If we look across all our customers, and that's what we typically do, is we basically monitor all the activities, identify issues, and then basically understand the root cause of these issues, make sure we can properly isolate them, and find a fix for them. Either it's an upgraded version that's already been pushed out by the open source community, or it's something that we go in and fix. And across all our customers, we have about 500 to 600 postmortems a year. Not saying that every customer runs into or will experience the same issues. What we actually do is we go in and when we identify an issue for a single customer, we go in, identify the root cause, fix it, and then deploy that fix to all customers at the same time, basically making sure that no customer runs into the same issue. But you will actually face quite some issues in production, and those 50% that have already specified that they are running Kubernetes for multiple projects will have made that experience. There are some companies out there that basically have 10 people just firefighting all day long. Yeah, that's just due to the, let's say, relatively new technology that is available, and that yeah, you need to consider when you basically think about how to set up your team and make it very effective. There are also new releases coming out, basically on a weekly basis for all kinds of projects. There are CVEs published, so security patches and issues published quite frequently. So you need to make upgrade and maintenance part of your everyday procedure. So that's where a lot of time goes, and that helps you really make the most out of the cloud native platform, providing the level of security, the level of reliability, the level of performance to your projects, making sure that they can basically push out their products live and don't have to worry about the infrastructure going down. For those who are quite new in the space, I just posted an example of a tenant cluster. That's what basically where your microservices would run on top. And as you can see, there are lots of different technologies that have been used in our standard setup. It might be very, very similar to what many of you already run in your tenant cluster architecture, but there might also be some changes. What we typically do is we are opinionated to that extent that we have made experience of what works well together, but we are also very open. So if there's a special use case that requires a different technology, then that's what we will integrate. If there are new projects that come out that basically can replace older ones but provide additional value add, then that's also something we take care of in terms of replacing, and that's something you need to consider also for yourself. So if we now basically have a good understanding of what the cloud native stack looks like, we can now turn into and look at what different operating models you typically can group the customers into. I believe this is very similar to what Gartner also published a while back. So typically you can group customers or companies into 4 different sections that where one is they basically cover everything internally. So they go out and install open source technology, use that to build their own cloud native stack. It's great because the technology is open source, so freely available. You can just install it very simply. You can then extend it with different applications. So you start off with a Kubernetes and then install a Calico and a Kibana and a Prometheus and so on and so forth to cover certain aspects. And you build up that knowledge all by yourself. Another approach is to use public cloud provider offerings like EKS, GKE, AKS, where you basically then get Kubernetes from your public cloud providers, which you can turn on. But you still need to monitor and manage everything in that space. And that's where we see a bit of a difference to the container management platform, is that you will need to install additional applications for your basically cloud native stack on top of that and manage that yourself. So that's basically a big difference between the public cloud providers and the container management platform that can be quite sophisticated. So there are some vendors out there that have been around for many, many years, and they provide basically a distribution of Kubernetes and many aspects on top that form the basic setup of your cloud native platform. And that you then basically can take, as you know from Linux and others, and install it on your machine, and then or in your data center or in your cloud platform, and then you can manage that individually. So here you basically the internal team covers everything from monitoring to issue identification, isolation, reporting, working through the support process, and so forth and so on. And then there's the fourth stack, which is where we find ourselves, where we basically offer a fully managed cloud native platform. So we take care of building that up, monitoring it, and then naturally upgrading and handling all the issues. So where your internal team then basically takes care of defining access right policies, integrating CI/CD pipeline for improved automation of and efficiency of your development teams, where you might need to help your internal teams migrate from a legacy application to a cloud native application architecture. And this this aspect can naturally take up quite some time and resources. In general, I would say the more time you can invest with your development teams and making sure that they are really become DevOps teams, the more you can, the more benefits you can get out of your cloud native platform, and so that light gray bar can actually get a lot bigger depending on what your perspective is. So far, we basically limit our perspective on the cloud native platform, but naturally there's a whole area on top. And I think from the registrations I have seen, there are many service companies also that registered for this webinar. This is typically the area where the service companies come in and help customers either migrate or build new cloud native applications, and that then basically need a cloud native platform to run the microservice application on top of it. So let's dive into each of these potential setups and quickly look at the advantages and disadvantages of the setups. So here, basically, we've got the first use case where we have an all internal team. So what you need to do is you need to find the right people within your organization, typically either in part or in full from your operations team and your development teams. Then you need to make sure that they can assess and build the cloud native platform from scratch. You can either train them or get them trained through external help, or let them make their own experiences. There are very smart guys out there and ladies that actually that have built up a tremendous amount of knowledge in this space. So there are companies out there that basically take this approach, and they constantly then extend the platform and monitor everything and take care of issue resolution. So the clear advantage is it follows the same mantra as you do with cloud native applications, which is you build it, you run it. So everything that you have built is something that you can fix yourself, which is a huge advantage in terms of really making sure that you're self-sufficient and that you can fix issues really quickly, especially if you've got applications that are running 24/7 with a very high percentage of uptime. That's where you really play out the advantages of knowing the whole stack all by yourself because you built it. A second aspect that drives many companies in that direction is the motivation of team. Naturally, new technology like Kubernetes is exciting. The development teams that then want to build these exciting and engage in these exciting projects, they prefer building up the stack themselves, so they can basically build up their knowledge and experience everything themselves to then really go in and manage something that they have built themselves, which is a strong driver for retaining and extending the, let's say, the development capabilities of your company. And also you'll be very fast integrating upgrades and patches. So if you've got a latest release, let's say every 30 days, every 3 months from Kubernetes, and you have new releases every day on other projects, you're very flexible in integrating them very quickly. And I know from companies that basically don't take more than 2 to 3 weeks to be on the latest Kubernetes version. So that's a great advantage of being in full control of the stack. The disadvantages naturally is that you need resources to do it. You need resources to build it. Just to give you an idea of what other customers have experienced, building up a platform took up about 40 people over 2 years, about 1.5 to 2 years, and then they basically still have 10 people that operate it on a daily basis, and that actually is a drain of your resources that basically focuses on something that doesn't help you differentiate. Having a cloud native stack is something that nearly every company will have in the near future. So it's something that is freely available. What you build on top differentiates you from your competition, and that's something you need to think about, especially on a management perspective. Is how can you really reap the benefits of cloud native as fast as possible. I already covered that aspect. Is where the second aspect, which is it takes a long time to get up and running. We've talked to customers that have done it themselves. That basically is all state something in the range of 1.5 to 3 years to build that up and to get everything up and running, making sure that everything works. Now, this very much depends on the scope of your project. So if you actually want to get something up and running very quickly, it shouldn't take very long, maybe a couple of weeks. And most service providers already know that story. They typically have have something up and running that supports them in their development very, very quickly. What I'm talking about is real complex day-to-day operations of production environments across multiple projects. So where you basically then need a lot of automation, you need to take care of multiple clusters, you need to take care of security aspects, and so on and so forth. So where basically everything is included and make sure that the automation helps you sustain operation very, very efficiently. And another part is naturally you may still need support contacts. So if you actually run into an issue of an open source product and find yourself spending a lot of time on fixing the issue, that's where a support contract may come in very, very handy, where you can ask questions, get the support ticket flagged, get someone to fix it, and then provide you with the fix. So that's something that you might want to consider. And another aspect that we have encountered also quite a bit, nearly half our customers, that our key stakeholders who actually were driving the Kubernetes project got hired by a Google or moved to another company, or basically all the aspect of employee retention becomes very, very important. Now let's look at the next, which is basically the public cloud provider that provides you with a full physical infrastructure virtualization environment, where you may need to move your provision your people with access, and you may need to move your machines and so on. So there are some aspects in terms of operations that are not covered, but I would say in the technology space and at least half of the operations space, then that's what they cover very, very nicely. In terms of Kubernetes, there are offerings at a different level, so that's why there's a shade in the graph for the technology and also for the operations side. The operations side covers upgrades that you're provided with, but that you need to run yourself, and you naturally need to take care of the monitoring and issue isolation and reporting and failover architectures and many other things that are not provided. And in terms of technology, you basically will find yourself in a space where you get a Kubernetes, for example, but need to build monitoring, logging, security on top of that. So you might end up getting more technology than you are provided with from the open source community, which brings you very, very close to your original setup of building everything yourself. It naturally has advantages, as you can quickly start very, very easily by just turning it on. And you're naturally also provided with upgrades. Also, it's as a default, very well integrated into the public cloud offering of the global cloud provider, and you will be able to install naturally additional applications on top, as the Helm chart is typically also nicely integrated. And you're also used to the support you will be getting, which you already have for your public cloud infrastructure. And if you're very, very happy with that and you think that is sufficient, then that's naturally something that plays to the advantage of the public cloud provider. There are also some disadvantages, which is that there's still a lot to do, as I mentioned. You still need to take care of managing the additional apps, monitoring them, all the maintenance aspects of this, issue identification, isolation, resolution that you will have to take care of. The resolution part may be covered then by the public cloud provider if you can isolate the problem and then report that as a bug and it's fixed. If it is because you have a certain setup or an additional app doesn't work the way that it was designed, then it actually falls back on you. So that's where you still have a drain of resources that focus on something that doesn't have to differentiate you from your competition. You also might end up with a potential vendor lock-in. So the public cloud providers try to differentiate themselves not by just providing the resources and being cheaper, but also by adding services on top. And that's something that then potentially may lock you into certain aspects to a single cloud provider. So it makes you switch from a cloud provider to another more difficult. And if you want to switch to a different Kubernetes setup or whatever, it may also be more difficult than going with a pure open source solution. And while you have support from the public cloud provider, you still may need additional, let's say, support from open source projects or for open source projects in case you run into any issues with that solution. Now let's come to the third one, which is the cloud management platform with support. That's where you can really start off fast with or faster than building it yourself. Typically a bit slower than with public cloud providers because you basically need to install it, and so you need to get your team trained and make the experience and how to properly configure and set everything up. You naturally can get help with that, so that can speed up the aspect again a bit. The advantages thereby are that it actually is a lot faster than building it up yourself. And that you can typically very well extend the platform with missing functionality if you need to. Also, there are about 100 distributions out there, so there is a wide variety to pick from. And that naturally upgrades are provided, which basically covers some aspects of the 24/7 operations. And you also get the support. So you basically can rely on someone to help you out in case you run into any issues. The difficulty here is that the operation is still on your side. So you basically need to monitor everything. You need to make sure that the upgrades work, that all pieces work together nicely if you put anything on top of it. And that you basically, once you identify an issue, that you can identify the root cause, isolate it, and then report this back to the container management platform provider, so they can then basically fix it. Or if there are further upgrades out there, then you may be at your own risk to upgrading, let's say a Calico or whatever, and to a newer version. And that may not be supported or not yet supported by the container management platform provider. So that's something that where you need to get a clear picture of what the support agreement covers and what it doesn't cover. There are some solutions out there that also provide a strong lock-in. So we already experienced customers that actually wanted to move to us, but then basically ended up having to rewrite substantial parts of the application because it actually was it heavily relied on functionality that was specific to that container management platform provider, and that basically created a lock-in. So if you actually pick one, make sure that it actually is based on purely open source Kubernetes, and your customizations or the functionality that that you may want to use in your applications are also available in a generic format and not in a custom format. And while you get upgrades, you might sometimes need to wait quite a while for new versions to get, or releases to get included. So if you look at Kubernetes, and there are some providers out there that basically will have you upgraded, or will provide you with the latest Kubernetes version within 6 months. That means you're always lagging 2 releases behind. If that's not a problem for you, that's fine. If you actually would like to really provide your developers with the latest functionality, then may become an issue for you. So then look at Giant Swarm, where everything is bright. Naturally not. We actually provide a fully managed service. And that's from our perspective, that's where we basically take care of everything from the technology stack. We only purely use open source technology, but we then also manage that 24/7. And we make sure that it's either installed in your public cloud account or in the data center. It's configured, secured, monitored, and any resolution that we identify or you identify is being taken care of, and the resolution is then basically implemented as quickly as possible. The advantage naturally is what we see is the shortest time to production, because we actually already have a stack, we already know the stack very well, and we deploy the same stack to every customer. That helps us be very, very fast in terms of identifying and resolving issues and making sure that customers don't run into issues at all, or we fix them before they even notice, before they even run into an issue. So this helps us be very efficient, and we can be up and running as fast as in a single day. So this is something that you might want to consider if you've got big time pressure. Yes, we are opinionated, as I said before, because we've made our experiences and see what's running best and what isn't. But if you've got use cases that may require a different setup, then that's naturally something that we can facilitate, and we basically make sure that when there is something like this, then we install the app, we make sure that it runs and provides you with the configurations that work with the security, with the network policies, and so on. And we also upgrade to the latest versions within 30 days. And fix issues immediately, so push out upgrades permanently. That's because we basically guarantee an uptime for master. That means the orchestration layer, but also for the clusters, for the tenant clusters, with a guarantee of 99.95% at least. So that's where we basically go in and provide you with upgrades, or basically make the upgrades for you if you want to make sure that everything stays up and running, and we don't run into an issue that we have already identified and fixed somewhere else. Then actually some disadvantages which I don't want to hide. One is you will get a full service from day one. So we actually provide you with a 24/7, 99.95% uptime guarantee from day one. So if you actually are not clear when you're going live, it could be in a half year, in a year, in 3 years, with your cloud native application, then you may end up paying for something that isn't providing you with the value that you typically find when moving quickly. So get us involved early, not a problem. We can talk, we can specify what setup we can click over very easily. But an important aspect is that it's a 24/7 operations with uptime guarantee. So if 24/7 is not an issue, and we've run into some customers that basically say, well, if we take care of a problem next morning, that's sufficient, then that might not be the right fit. Another aspect is that all customers run on the latest 2 versions. As I said, we basically take responsibility for uptime. So we make sure that that all the risks that are created by issues that may have already been fixed or that we fixed, that they don't show up again. So we make sure that all customers always stay up under the 2 latest versions of Kubernetes, and especially Giant Swarm versions that basically are a defined set of Kubernetes and 20-30 additional applications. They always stay up to date to make sure that there are no security issues, there are no performance issues, and so on and so forth. So if you want to stay on an older version for longer, then that's something that you might find to be more applicable to a different scenario. So time is flying, so I'll just speed up a little bit. So what does effectiveness mean? I said, we'll actually come up with how you can build your the most effective enterprise Kubernetes team. Things mean something different for different people. You've got this magic triangle. You've got the scope, which can include 24/7 operations, 99.9% availability, and so on and so forth. You've got the time, so how fast you need to get into production, and naturally the cost aspect. Typically, cost is tightly coupled to scope, but we quickly dive into one of or every one of these aspects. So if you've got a single project, then you might be fine with a simple setup. If you've got multiple projects or an enterprise platform, then that's a totally different story. You need to, in terms of scope, you need to support different use cases, different teams. You might need to support on-premise and public cloud. You might need to support one or multiple cloud setups at the same time. You may need to support regions like US, Europe, or China, which is also very different in terms of what public cloud providers provide, for example. Then 24/7 on 99.9% availability are things that define the scope. And naturally then different use cases, like one could be an online shop, the other IoT, the third one big data. So that then basically defines how complex your setup becomes and how much in terms of scope you require for your Kubernetes platform. The other aspect is naturally time to production for the platform. We had customers calling up and saying that they tried it with others and it didn't work, and they need to go live in a month. So can you help us? And that's something that we're quite good at. So time to production for the platform is naturally essential. If you don't have time constrictions, if you're just wanting to play around, then it might make sense to do it all by yourself initially. Then time to security fixes, upgrades, and extension is something that depends on how vital the application is that you're running on top of the cloud native platform. Time to market, if you want to embark in other markets, also the enablement of your teams can be a quite decisive factor. So how much time your internal resources will need to then help your development team come up to speed. Also time to changes. If you want to change a cloud provider, if you want to add another cloud platform, that's also a question of how quickly can that be supported. and naturally the time to value. So how much value can your company reap from the cloud native approach, and that highly defines then basically your options that you can take. The third one is the cost, build versus buy, naturally. Typically, probably you will invest as much time and effort, at least, in building up a platform over time than you would spend buying. But I think the benefits lie somewhere else. It's really running something that you built and that you actually know how everything works. You need an internal team that you need to put together. You need to train it, build the experience. Salary is an important aspect, which is something that basically can be quite high for site reliability engineers. In Germany, I read something in average of at least 75,000 euros. In the US, someone with Kubernetes experience would get something like 140,000 euros in average dollars. The rising demand for experts in this space has increased salary quite a bit. So this is something you need to take care of, and naturally also retention. Then you have aspects of 24/7 operations. So you need to have different people that can work in shifts to then monitor the system and go in and fix it. I typically would assume you need about 5 to 6 people to manage that 24/7 around 365 days, and they need to be experts, so they need to be able to go in and fix it. You also need to focus on the development team enablement. So if you build a platform and your development team is taking a lot of time understanding what cloud native means and how that impacts the application, and then basically has a long learning curve, then that actually reduces development efficiency dramatically. So that's something you need to consider in your analysis. Also, if you want to do lift and shift, you might want to go with a platform that provides that very easily or has built that way. If you want to migrate or rebuild it, that also then has an impact on the time and when you actually are going to invest in such a technology or support. Lock-in that may require you to spend more money reworking your application later on to move it to a different platform, and most importantly, opportunity costs. So how much does it cost if you actually go to market later? If the performance or response times, for example, in Adidas case, they managed to reduce the response times dramatically, and they assume that the revenue has thereby increased by about 20%. So opportunity cost in that respect, especially also downtime. So if something goes down on Black Friday, then that actually is the worst that can happen to a retailer. And it hasn't happened to several of them. So that's not something that is theoretical. Just to help you guide your decision, effective Kubernetes team, as I said, scope and cost is tightly aligned. So basically, I drew up a two-dimensional graph with scope into the y-axis, and the x-axis is the importance of time, so not how long it takes, but actually how important time is. And if you actually look at where I would position them, basically, if scope is limited and if time is at abundance, then internal teams make total sense. If you actually have less time and the scope needs to be a bit bigger, container management platform makes sense. And we actually see a great advantage if you actually have a need in terms of time and a larger scope than to go on a fully managed service. I hope that actually helps you position that or get an idea of how to position that. It leaves me with the question, what is left for the internal teams if you go to a fully managed platform, which then basically is that you need to enable your teams to move to microservices, automate the continuous integration deployment cycle, make sure that that actually becomes more and more efficient. Also enable your teams to basically go full DevOps and then provision the different containers or clusters for your team so they can basically use the infrastructure as quickly as possible. Now, since I'm a little bit over time, just quickly speed up with the final slide. So the key takeaways from this presentation, I would say are you need to make up your mind what value lies in cloud native for your company. If it's only a small department, a small project that isn't very critical, then it probably might not have the importance of having a fully fledged system up and running immediately. If you actually are committed to cloud native, if you're transforming your whole company to agile, then it's actually mandatory. If you look at the engineers from a perspective, what you actually will need, you would need someone to take care of cloud platforms and automation, someone takes care of observability, site reliability, and naturally solutions with the team engagement. The question most important is not what can you do, because I'm pretty convinced that you can do everything, but what should you do? What makes most sense from an economical standpoint and from a technology standpoint? And that's something that you need to get your head wrapped around. I hope the presentation helped a bit in that respect. I strongly believe that if the internal teams that are already available and taking care of operations more focus on how to enable your development teams become more efficient and move to cloud native faster, the higher the value for your company. So with that, that was a very quick run through. So hopefully you actually found that very helpful and insightful. Again, if you've got any questions, then send us an email to hello@giantswarm.io. I actually am naturally available for questions. I'll just quickly check. So those of you actually who are who've got a little bit of more time can stay on, and I'll see if I can run through these really quick. Just going through the messages. Good, very good. So one question is, so what is left over for the service providers? So what, yeah, as I said, there are many service providers, and what is, how do we work together with them? A very important aspect, and that's something that we see, and we work together with many service providers that basically transform an application from from a monolith to a cloud native environment. Typically, we find that they are they're very good at getting the customer from, let's say, from a understanding of what used to be software development into what it needs to be in terms of DevOps and the microservice architecture. Excuse me. But then also transforming that application. And what we actually see, and that's why we've been working together very closely with service providers, is that they basically take over the aspect of getting the application, but they typically don't want to run the cloud native stack. So they are fine with operating 24/7, even for the application and providing support for the application itself. But then basically the whole cloud native stack, which can then span across different use cases and so on, different teams. That's something that typically is something they actually don't want to cover. So that's how we typically work together. I hope that that answers the question on how we work together with the with service providers and actually what is left over for the teams. Any other questions? Oh yeah, that's a very good one. So what about knowledge transfer? So if we actually give everything outside of the company in terms of fully managed solution, what happens to the knowledge that we actually then don't have internally? Are we basically, is there a lock-in? And that's an excellent question, because that's something that we basically experience over and over again, that the reality is actually quite contrary. So every customer that we work together with has a dedicated solution engineer that he can basically contact anytime via Slack. And our average response times are at about 2.5 minutes. So basically, whenever I've got a question, I can ask someone, and I get someone who actually has great experience in Kubernetes answer that question for me. I save a lot of time, but I especially build up tremendous knowledge in Kubernetes. And we actually have customers that are highly skilled, and they have grown into highly skilled people very, very easily by just working very, very close together with us. So the knowledge transfer aspect isn't no issue at all. It's actually it's more the contrary. It helps you build up knowledge a lot faster than you probably could do all by yourself. Good. So I think we're about 7 minutes over the time by now. I'll cut short now. I hope you enjoyed the webinar. We'll have more webinars coming up. So join us in the future too. If you've got any questions, send an email to hello@giantswarm.io. If you would like to talk to us about your setup, then also reach out to that channel or visit us at AWS reInvent. And we're very much looking forward to understanding where you stand and how you actually are planning to advance. So thanks very much for joining today, and hope to see you again soon.